turning point. If A is greater than 0, that would mean the graph is concave up. If A is greater than 0. Whereas if A is less than 0, the graph will be concave down, like that. So A tells us about the shape. Now let's look at x1, x2. x1, x2. If we are to use that example, we've got x1, x2. x1, x1, x2. So as I've indicated, x1 is to 0, x2 is to 0, which means these are our roots or our x-intercept. These are our x-intercept. Our x-intercept or our roots. Same as you can see there, which means here, if you were to find the roots here, you were going to say x1 is minus b plus or minus, or it's plus b squared minus 4ac over 2a. It's minus b plus. That is our x1. This is to 0. Or it's minus b minus b squared minus 4ac. This is all over 2a is to 0. It's x1, x2. These are our x-intercept, And then after finding the x-intercept, remember, you just use this. This is your x value at the turning point. X is equal to minus b over 2a. Use this to find the value of x at the turning point and take that x value into the original equation. Right, and then we've got again this equation. H at x is equal to a into x minus p all squared plus q. A into x minus p all squared plus q. Right, we've got this. X is to y. Our y is given by h at x. This is endpoint or given point. That's the given point. That's the given point. Same meaning as that one, the given point. And then, as you can see, this is a quadratic because when you are to solve there, for instance, you have x minus p into x minus p. So x times x is x squared, which will give us a quadratic function. Right. And then we've got the value of a, which tells us about the shape of the graph. We've got the value of p and q. P and q tells us about maximum or minimum value. P is to q. P is to q. This is our turning point. That's our turning point. So the given point, the value of a, and the turning point. Right. If you are to look where we were to solve for x, by completing a square, we had this, it was x plus b over 2a. X plus b over 2a. This was equated to b squared minus 4ac over 4a squared. We had this. Let us transpose this to the left. It's x plus b over 2a all squared minus b squared minus 4ac all over 4a squared. This is equal to 0. Right. In terms of this, it's x minus p, which is represented by x plus b over 2a. So here, in the place of p, we've got b over 2a. In the place of q, we've got that. Which means here, if you are to find the turning point, you just solve for x there. You've got x plus b over 2a equals 0. Therefore, transpose x is equal to negative b over 2a. That's what we will have to do here to find the turning point. You just take that. It's x minus p equals 0. And then you solve for x. X will be equal to p. This is the x value at the turning point, same as that one, where you were to solve there. And then this is the y value, which is represented by q. That's the y value at the turning point. Therefore, the y value at the turning point is given by minus b squared minus 4ac all over 4a squared. All over 4a squared. Therefore, if you are to write this in coordinate form, it's negative b over 2a is to minus b squared minus 4ac over 4a squared. Over 4a squared. This is our turning point. That's our turning point from that equation. X minus p plus q. Right. As we are saying that the value of a tells us about the shape of the graph. It tells us about the shape of the graph. The value of a. If a is greater than 0, we said the graph will be concave up. If a is less than 0, the graph will be concave down. Right. This means that if a is greater than 0, we are going to have a minimum value. A minimum value. Only if a is greater than 0. But if a is less than 0, we are going to have a maximum value. We are going to have a maximum value. So, a is greater than 0, we have a minimum value. A less than 0, we have a maximum value, which means for minimum, a must be greater than 0. For maximum, a must be less than 0. Right. Right, before we go to examples, let us now look on what we call the inverse of a quadratic function. The inverse of a quadratic function. Right? A quadratic function is given by this. It's ax squared. It's ax squared. Right? If you are to write the inverse, remember, we are to firstly write f as y. Because this is y. It's y equals ax squared. And then after, we swap the points. X is equal to y squared. And then from there, this is our inverse. This is the inverse. It's the inverse. And then, if you are to write the equation of the inverse, you make y the subject of the formula. This is the inverse. It's not the equation of the inverse. It's the inverse. If you are to write the equation of the inverse, make y the subject. Therefore, we have ay squared is equal to x, and then let's divide by a. We divide by a on both sides. Now we are having y squared is equal to x over a. For y to be the subject, we are to get rid of squared there by putting a square root. Therefore, our y will be equal to plus or minus. It's plus or minus x over a. That's the inverse. Meaning that the inverse of a quadratic function will have a root sign. The inverse of a quadratic function will have a root sign. You can be given this as a function and being asked to go back to find the inverse of that. For instance, let's say you have a g at x. G at x is equal to plus or minus square root of x over 2. Our a is 2, right? And then you are to write this. Let's say you are being given that this is the function, and you are to find the inverse of that. You write this as y plus or minus square root of x over 2. And then from there, remember, we swap the points. This will be x plus or minus square root of y over 2. We are swapping the points. This is the inverse. It's the inverse. Here, we said this is the equation. Equation of what? Of the inverse. That's the equation of the inverse. Right. This is the inverse. We need to find the equation of an inverse. In order to find the equation of the inverse, again, we need to make y the subject. For y to be the subject, we are to square on both sides. We square on both sides so that we'll get rid of that square root. Here now we are having x squared, which is equal to, you will be left with y over 2. It's y over 2. And then we multiply by 2 on both sides so that y will be the subject. We multiply by 2 on both sides. This divides that. Now we are having y equal to 2x squared. This is the equation of the inverse. Equation of the inverse. The equation of the inverse. Right. Now let's look. We've got this shape. When we talk of a quadratic function, you have h at x is equal to 2x squared. H at x is equal to 2x squared. If you are to sketch this graph, let's use the table. Right. It's x is to y. X is to y. Let's put -2, -1, 0, 1, 2. Right. Remember that function, it's about what happened to y as x increases. That's the reason why we are writing numbers like that. X is increasing, we want to see what will happen to y. If you are to put -2 in the place there of x, it will be -2 squared, which is 4 times that, it's 8. -1 squared, it's 1 times 2. And then put 0 there, it's 0 times 2, that's 0. Put 1, it's 2, put 2, that's 8. So, to sketch this graph, you see we've got a -2, it's 1 and 2. We've got negative, let's start from here, 0 is to 0. -1 is to 2. One is to 2, should be there. -2 is to 8. And then one is to 2. 1 is to 2. 2 is to 8. If we are to join the points, -2 is to 8, 2 is to 8, 1 is to 2, -1 is to 2. Right. When you look here, we've got different values of x for one value of y. Different values of x for one value of y. Again, y is equal to 8, y is equal to 8, but x is equal to -2, x is equal to +2. We've got two different values of x for one value of y. That means this is a function. This is a function. Or we said it's a function of h, let's put h. H is a function simply because we've got two values of x for one value of y. Two values of x for one value of y. Let's say you were having -2x squared. We just want to check that one. F at x equals -2x squared, like that. So now we have changed the coefficient. right, we've got x is 2, 1, negative 2, negative 1, 0, 1, 2. So if we are to put negative 2, it's 2 times negative 2 squared. This will be 4. 4 times negative 2, it's negative 8. We put negative 1 again in the place of x. Negative 1 squared is 1. 1 times negative 2, that's negative 2. We put 0 now in the place of x. 0 times negative 2, that is 0. Let's put 1 in the place of x. 1 times negative 2, that's negative 2. We put 2 in the place of x. 2 squared is 4. 4 times negative 2, that is negative 8. Right, let's sketch this graph using the same Cartesian plane. Let's say here we have negative 2, negative 4, negative 6, and negative 8. Right. We have 0 to 0. We have negative 1 is to negative 2. X is negative 1, y is negative 2. X is negative 2, y is negative 8. X is 1, y is negative 2. That's where it is. And then 2 is to negative 8, like that. Let's join our points. Right. That's how our graph will be. This is the function of f. We've got 1 is to negative 2. Again, here we've got negative 1 is to negative 2. Here it's negative 2 is to negative 8. 2 is to negative 8. Right, when you look again here, we've got two different values of x for one value of y. Y is negative 2 if x is equal to negative 1. Y is negative 2 if x is equal to positive 1. So we've got two different values of x for one value of y. Two different values of x for one value of y. Which means f is a function. F is a function. Right, looking at the vertical line, you can move it either to the right or left, either to the right or left. It will cut this graph once. It doesn't matter, either you move it to the right or left, it will cut the graph once. That's why we are saying h is a function, because a vertical line cuts that graph once, which means it has got only one y-intercept. Right, using the same graph h at x, h at x equals 2x squared. Let us find the inverse here. It's y equals 2x squared. And then we swap the points. X will be equal to 2y squared. We want to sketch this graph for the inverse. It's x, y. Let us sketch this one here. We want to find the value of, or now our x is the subject, which means we are to find what will it be. If x is -2, what will be the value of y? But then since x is the subject, let's swap again here. Let's swap. Since it's the inverse, let us make it simple. Let's say y is to x. Y is to x. We are swapping them now. Let's see. Y is -2. What is the value of this? No, let's use same way. Let's just swap the points. It's 2, 4, 6, 8. Right, it's 1, 2, -1, -2. Obviously, we are just swapping the points. Those are the points that we are going to use for the positive one. And we've got x, we've got y. And then if you are to swap these points, we are swapping them. In other words, in the place of x, we put y. So if x is equal to -2 on that function, y is equal to 8. But now, since we are swapping them, which means we are going to have 8, 2, 0, 2, and 8. Here, it's -2, -1, 0, 1, 2. Let's sketch this graph. It's y and x. Right. If x is equal to 8, y is equal to -2. And then if x is equal to 2, y is -1. If x is equal to 2, that's 2, 4, 6. 0 is to 0. And now y is equal to 1, x is equal to 2. That's where the point is. Y is equal to 2, x is equal to 8. And then we join the points. Right, this is the inverse of that function. So to indicate that it's an inverse, you write it like that. We have the coordinates of this point, which are our x here, 2 is to 1, 2 is to -1. We have 8, 8 is to -2. Here we have 8 is to +2. Right. When you look here, let's start from here, 0 is to 0, and then here, x is equal to 2, x is equal to 2. Y is equal to 1, y is equal to -1. We've got one value of x, but we've got two different values of y. One value of x, two different values of y. On that situation, we said a function must have one value of y for two values of x. That's a function. But if it has got one value of x, as you can see here, one value of x with two different values of y, that won't be a function. Because now, if you look, it's either you move your vertical line test any of the points on this function, it will cut this graph at 2 points. It will cut the graph at 2 points. Any of these, if you are to move a vertical line, it cuts the graph at 2 points, it will be no longer a function, because a vertical line test cut this graph twice. It's no longer a function. A function, you'll see a function by when you are to use a vertical line test, it will cut it once. Since it cut it twice, it is no longer a function. Right. When will this be a function? Right. This will be a function only. Let's redraw this. Right. A function of h, or this is the inverse, right? For that to be a function, for this to be a function, you need to remove this part. You need to remove this part. After removing this part, you see now, the vertical line test cut the graph once. See, it cut it once. The vertical line test cut it once. It's either you remove this part or